and welcome to today's webinar. My name is Lisa Shaw, and I'm the Digital Specialist at SICK. SICK is one of the world's leading manufacturers of sensors and sensor solutions for industrial applications. Today we are taking an inside look at the updated ANSI B11.19 Standard. During this webinar, the first of a four-part series, you will learn the structure of B11 standards, the organization of ANSI B11.19, about the nearly 20 new measures for reducing risk, how the standard differs from previous editions, and so much more. Just a little housekeeping before we get started. A recording of this webinar will be emailed to you following today's presentation. Also, feel free to ask questions at any time during today's webinar by typing your questions into the Q&A section in your control panel. We'll take some time at the end of today's presentation to address as many questions as time allows. Now, without further ado, we'll turn our time over to today's presenters, Chris Serrano and Dave Felinsky. Dave is the president of B11 Standards, Inc., ANSI's B11 Secretariat, and has over 45 years of experience in the field of industrial safety. Chris is a Safety Standards and Compliance Manager at SICK. He is a certified functional safety expert and is a member of numerous ANSI committees and international standards working groups. Chris and Dave, please take it away.
So thank you very much, Lisa. Good morning, everyone. My name is David Felinsky, and I'm president of B11 Standards. And I'd also like to add my warm welcome to everyone, and thank you very much for your participation today. I'm going to assume that it's because you're riveted and fascinated by the subject matter of ANSI B11.19, the new standard, and not because everyone's homebound and or travel restrictions and so forth, but it's just the standard, clearly. But we have a very good participation rate today, very high participation, and we hope to deliver the goods for you. So just a little bit of background about ANSI B11 standards. We are one of approximately 230 organizations around the United States that are accredited by the American National Standards Institute to develop American national standards. The topic of our standards are the safety of machinery, and the designation is ANSI B11. So the scope of our standardization activity is essentially the standardization of concepts, general principles, and requirements for safety of machinery, incorporating terminology, methodology, and risk reduction measures for new, existing, modified, or rebuilt power-driven industrial and commercial machinery that is not portable by hand while working. It also includes associated equipment that may be used in the production system. So currently, our portfolio of standards encompasses 35 individual documents. About 2/3 to 3/4 of those are actually standards. The rest are technical reports. We are coming upon our 100th anniversary, ironically. In 2 years. It will be 100 years since the very first B11 standard was published. That was B11.1 on the safety requirements for mechanical power presses. We've gotten very verbose in that 100 years. That standard was only 6 pages. Now the current B11.1 is about 130 pages. Each of the individual standards, as well as technical reports, has its own individual writing subcommittee that are composed primarily of experts on, subject matter experts. And this is overseen by a committee called the B11 Standards Development Committee. This is actually the committee that is the recognized consensus body of the ANSI B11 series of standards and technical reports. There are currently 32 organizational members on that committee. Most of those organizations are either large trade associations or they're professional societies. We have several large corporations like, for example, Deere, General Motors, Toyota, Boeing, etc., as well as a number of smaller corporations. And in addition, we have both NIOSH and OSHA that are members. We used to have the United Auto Workers. However, they have dropped off the last few years, probably funding, but nevertheless, you can see that it's a very broad-based coalition of organizations. It's not just simply industry-focused in that regard. And The B11 Standards Development Committee is the body that essentially decides the strategic direction. They consider the development of brand new standards or new areas to standardize in within our scope. And they also coordinate and strategize on how to deal with or harmonize with the ISO and IEC standard portfolio that deals with the similar subject matter. Now, what I'd like to do is talk just briefly about two of the main, I'm sorry, next slide, yeah. Just to mention, in addition, the B11 standards is also the United States Technical Advisory Group administrator to 3 different ISO technical committees, ISO TC199 on machinery safety. That's the home of the vast majority of standards, which many of you are probably very familiar with, like ISO 12100, or 13849, et cetera. There's about 40 standards in their portfolio. ISO TC270, which is a new technical committee on plastics and rubber machine safety, and also subcommittee 10 of ISO TC39, which is on machine tool safety. So as the tag administrator, B11 Standards coordinates the input of the United States into that ISO process, and we do that through our ISO member, which is ANSI itself. Now I'm going to talk just very briefly about 2 of our main or formative foundational standards. That would be ANSI B11.0, which is a Type A standard dealing with the safety of machinery. Since I already mentioned ISO 12100, this standard is quite comparable to ISO 12100. However, it is about 25 years more current, even though the 1200 standard is a 2010 date. It, in effect, was last significantly revised in 1995. So the contrast that with B11.0, which is a 2020 standard. The other major difference is that it is much more comprehensive than the 1200 standard, dealing with not only legacy machines, but it also deals with user requirements, whereas the 1200 standard is silent on both of those. And then the other standard, which is the subject of this webinar, of course, is ANSI B11.19. That standard deals with safeguarding, which is now called performance requirements for risk reduction measures. And this is a Type B standard. However, there is a most significant Type B standard in our portfolio of B11 standards. Both of these standards were published at the very beginning of this year. So without further ado, I'd be pleased to turn this over to my colleague and friend, Mr. Chris Serrano, who is with SICK, and he is also the chairman of the ANSI B11.19 standard. Chris.
Thank you, Dave. I'll introduce myself as Chris Serrano. Dave and Lisa both introduced me already. I'll also pass along my warm welcomes, and we'll just continue on so as not to break up the flow here. So as Dave mentioned, there's an entire portfolio of B11 standards. So we'll talk kind of starting just conceptually how all the standards work together. There's a structure that was, I think, first developed by ISO. It's been adopted within the B11 family as well, where we have a stratification of standards. At the foundation, we have Type A standards. I consider this kind of bread and butter or kind of safety 101, the real generic, general stuff you need to know to build the foundation of safety on. It talks about general requirements that apply to really every industrial machine and the conceptual approach and the philosophy of risk assessment. Upon that foundation, then, we build with some more specific topics in terms of focus, but this is where we have standards that help us build the framework for the machine or the application that we're looking at. Just like building a house, you have to have a strong foundation to begin, and then as you design the house, there's going to be standards for how you build the walls and the stud location. There's going to be standards for the electrical and the gas and the electrical systems. All those things, if you're applying them, there's a standard for them. And very much in that analogy, the Type B standards within industrial standardization follow that same approach. When you're going to apply a certain type of application or measure, there's a standard for how it should be applied broadly across machine types. And then, sorry, in the wrong direction, building upon that then, at the apex, we have the Type C standards. So these are machine specific. it's going to differentiate requirements for a mechanical press from a tube bender, from an iron worker. There's going to be more specific requirements there based on the technology, the history, the type of the machine, how it's used in industry, and that's really what sets it apart from other types of machines. C-type standards also can be more specific based on the region or location of where the machine is deployed, and it's important that we recognize the means and the purpose for each of these layers of standards so that we can understand how best and when to use them, which as we look at the B11 standards, following that same approach, that stratification of type A, B, or C standards, the B11 family of standards, that whole portfolio that Dave mentioned, also follows this structure where the type A standard is ANSI B11.19 that Dave mentioned briefly. Within the type B level, there's a handful of both normative standards as well as informative technical reports. We see here ANSI B11.19, which is what we'll be talking about here today. And then the remainder of the portfolio within the B11 family are all machine-specific standards or C-type standards. So if we focus more on the lower portion of this triangle, the type A and the type B, and how they fit together with type C standards, as I mentioned, it's important that we understand how and when to use the standards, and it's important to understand that we can't omit one in favor of another. So when we look at hazard identification, identifying where hazards are, evaluating them, assessing them, and determining whether or not they're acceptable, B11.0 is the primary guide for that. It's a type A standard. However, when you get into machine-specific applications like a press, there's going to be unique requirements, unique hazards there that the body of experts that wrote that standard are going to be most familiar with and provide that more specific guidance. When we go to applying the risk reduction measures, this is where the type B standards come in, such as ANSI B11.19, with the general requirements for how to apply different measures. And then again, it's used in conjunction with the type C standard that's going to have more specific application requirements that are unique to the type of machine and how that machine is used. So this is intended as kind of an overview to understand that we're not focusing on the right side of this image today on the type C standards, we're more on the left side, but it doesn't mean that the type C standards should ever be omitted or overlooked because they are intended to be used together. There is more information available on this. Obviously within the standards themselves, SIC has an ebook, a safety ebook that we've published. I'll come back to this website at the end, but you can Google SIC safety ebook and find it very easily, and it gives a much greater detail of this approach and how standards are supposed to be used together. So from there, we're going to kind of talk about the left side of that image, how ANSI B11.0 and B11.19 work together and how they're supposed to be used. As Dave mentioned, they're both brand new standards. They were both approved at the very end of 2019. ANSI B11.0 actually has a 2020 publication date, so technically it's really only a few months old. In reality, they're both only a few months old, but nevertheless, again, we need to understand how these work together. So B11.0 talks about many things, again, the general requirements of how machines are built, but also focuses on the risk assessment process. So this is the guidance for identifying tasks and hazards, evaluating them together, understanding how risk is comprised of probability and severity, and then evaluating that risk to determine if it's acceptable. And when it's not, it then talks about how to reduce that risk and measures that can be taken by the supplier or the manufacturer of the machine to help reduce that risk. As Dave mentioned, it also goes further into providing guidance for the end user or the employer how to reduce that risk and the measures that can be taken. It talks about the collaboration that can or should occur between the supplier and the user when possible, and helps identify when risk is not acceptable, what type of measures should be applied. At that point, once you've selected the measure, you need guidance on how to apply the measure correctly, and that's where B11.19 comes in, with the actual application of the risk reduction measures. So as we see in both of these models for both suppliers and end users, there's measures that are laid out. They're in a hierarchical order, inherently safe by design, followed by engineered controls, followed by information for use. And the same structure applies to end users as well. It's often called the hierarchy of controls, but in reality, they're essentially the same thing. There's three main steps to them. Obviously, when we get to the end user side, there's a little bit more that can be done and beyond just informing of hazards, but other elements administratively that can be applied to reduce that risk. And then B11.19 provides guidance that can help with the validation and verification that the risk reduction measures applied are actually doing what we hope they will do by reducing risk. We then go back to the risk assessment process, reevaluate the risk, and determine if we've reduced the risk sufficiently to a tolerable level, to a point where we've achieved acceptable risk. So this is kind of a visual of how B11.0 and B11.19 play together. They both have their own purpose, their own focus, but collectively they're used as the elements to help reduce risk within industry. As Dave mentioned before, ISO 12100 is very similar to ANSI B11.0, but as he mentioned also, it only applies to machine designers or suppliers, integrators. Therefore, it can only apply to new machines placed on the market, but it does follow the same basic approach, the three-step method to reducing risk, and it relies on a wide variety of B-type standards that are available internationally to help with the application of those measures. To contrast that approach, ANSI B11.0 not only addresses the designer, but also addresses the end user, which means it addresses not only new machines, but existing machines in industry as well. And in addition, with the structure as it's laid out, the list of supporting documents, in contrast, is much shorter, partly because ANSI B11.19, as we'll see here today, has a lot of information pulled from many different sources and lots of experience, and puts it into one single document to make it easier for industry to apply. So, big picture, looking at this again, on the left side, we have the risk assessment portion and selection of the measures. On the right side, we have the application of the risk reduction measures, following and including validation of them. And so what we see really is this harmonized alignment between ANSI B11.0 and B11.19, where, at least in my opinion, these two together really form a very full, complete picture that can be applied across industry, not just within the B11 family of standards, but across industry as a whole, especially across the US. So now we're going to get into a little bit more detail of the standard itself, starting with how it's organized. The standard underwent a major revision from the previous edition in 2010 to 2019. And one of the major things that occurred was a complete reorganization of the standard. I understand the image on the right of your screen is a bit of an eye chart. You're not expected to be able to read it. What I do want to point out is all the boxes highlighted in dark green are all additional content that were added to the standard that was not there before. But also structurally, this is a nice visual to show how it's now aligned with the three-step method or the hierarchy of controls that is now incorporated into B11.0. So not only do they work well together, but they follow the same format, the same structure, and so it I believe, makes it easier to go from one document to the other seamlessly. So on the left, what we see is the hierarchy of control table, which is included in ANSI B11.0. And it starts with step 1, inherently safe by design. And by design, ANSI B11.19 follows that same structure, starting with clause 7. Clause 7 is inherently safe by design measures. In the hierarchy, we then have step 2, which is engineering controls. As you can see on the right, B11.19 has a whole lot of content addressing engineering controls. So for usability, it was decided to break that content out into 3 different subsections, each with their own clause. Clause 8 addresses guards, Clause 9 addresses control functions, and Clause 10 addresses devices. So the control functions in the middle could be applied to a combination of guards or devices, but there were more abstract theories and ideas and logical conceptions, whereas clauses 8 and 10 were on the actual component or device itself. And then at the end of the hierarchy, we have step 3, which is the administrative controls, which are then grouped together in B11.19 within clause 11. So structurally, as I mentioned, the idea was to have this nice clean alignment within B11.0. You do the risk assessment, you identify the measures you want to apply, and then you can go to B11.19 and understand how best to apply them to achieve the goal of reducing risk. So there was a lot of information on that other slide, including a lot of content that was not highlighted, which says that there was a whole lot of information in the previous edition of B11.19 that was useful and valid and still accurate, but it may not have been as organized as we would have liked. And so one of the elements, again, within the last activity of the revision was to realign those. And how they were realigned, how they were grouped together, again, was based on the risk reduction hierarchy of control and the 3-step method. So hopefully it makes it easier to navigate and use from a reader's perspective. Once we get into the document, it's also important as part of this reorganization to understand how it was written. So the first 5 clauses at the top are pretty much obligatory. They're required in every standard. What the standard addresses, what are the informative and normative references, what are the words we're defining and how we're using them within the standard, who's responsible for which parts of the stakeholders, whether it be a supplier or an integrator or a user or even the employee. An overview on the risk assessment process, obviously with reference to ANSI B11.0, and then we get into the real meat and potatoes of the document with Clause 6. So Clause 6 starts with just an overview of risk reduction measures, and in this Clause 6 lays out the most basic generic requirements of all risk reduction measures. So everything that follows after Clause 6 still has to meet the requirements within Clause 6, but we tried to centralize the most common elements so we didn't have to repeat them 40 to 50 times throughout the document. From there, we then go into the individual clauses, as I mentioned before, clauses 7 through 11 and how they address the different steps or sub-steps of risk reduction. And within each major clause, it starts with general requirements within those concepts. So clause 8.1, for example, is all the general requirements that apply to guards, in addition to the general requirements from clause 6.1. And then as we go further, with an example of looking at area scanners, for instance, there's going to be a clause 10.7.5, I believe, for area scanners. But at the beginning of 10.7, which is presence sensing devices, is another subclause with general requirements. So for instance, if I want to understand how to apply an area scanner, I should not jump only to the subclause on area scanners. I need to go up to the general requirements for presence sensing devices. I need to go up further for general requirements for all engineering control devices, and up one more level for general requirements for all risk reduction measures. So it might seem slightly confusing at first, but the intent truly was to streamline the document. The document's now over 250 pages long, and if we were repeating the same core elements or general requirements multiple times, that would have exacerbated that, and it would have been a 500-page document easily. So now we dig a little deeper and we look at the actual content within B11.19. And there's a lot of new content in here, as we mentioned before. In my view, our safety experts, the expert committee, the panelists, the members of the writing committee really took all of the knowledge and best practice and experience across industries and put it into this one basket of B11.19. So looking at just the clauses that address the risk reduction measures. I really just want to spend some time here and just highlight some of the stuff that was added as new. Obviously, there's a whole lot of content in here that can be found in the standard itself, but this webinar is intended mostly as just a primer and an introduction so you can understand the value of the standard. So within Clause 7, we address inherently safe by design. Again, Clause 7.1 on the left over here shows the general requirements. One of the new elements added to the first step of risk reduction was prevention through design. So what types of design measures or the methodology to apply design measures to the machine that will simply eliminate the hazard altogether. There's some existing content in the middle with safe opening safeguarding methods and safeguarding by location. And then we added a new clause for minimum gaps to avoid crushing of parts of the human body. So based on a risk assessment, if we can identify which part of the body is going to be exposed to a hazard zone, this section gives us guidance on what the minimum gap is to ensure that that part of the body is not crushed or injured to a point of injury. And then the last clause that's also new is maximum gaps to avoid exposure to the hazard. So the previous one was minimum openings. So make sure that at its smallest point, it's not going to crush me. In contrast, clause 7.6 is what's the largest opening that I can have that will prevent someone from getting into the hazard zone. That's commonly referenced as a 1/4 inch or 6 millimeters. And so giving guidance for that, these are all design measures that can inherently reduce risk on equipment. When we get into step 2 with the engineering controls, as I mentioned, there's 3 subparts to this, the first of which is guards. Again, starting with clause 8.1, general requirements for all guards. And there's a number of annexes within the document, which we'll see later here today, that help support the application of guards. We've added guidance for removable guards as their own type of entity for typically applied in low-risk applications. Interlock guards with, or movable guards with an interlock is referred to as an interlock guard. We had already included adjustable guards, but we've added self-adjusting guards. We know these exist in industry. It's important to acknowledge them and make sure that people think of these types of measures when trying to reduce risk. We've also added a section on perimeter guards. Most people are familiar with perimeter guards when you define an area with fencing, the perimeter guards that use that, and we have some guidance that was applied for those as well. We now have requirements in the standard that talk about a minimum height for a guard, for a physical obstruction to be considered a guard. If it's less than 55 inches, it's probably not going to obstruct intentional access to a hazard zone. So that's a minimum height, but based on reaching over that fence, it might be necessary to raise the height of that fence above that minimum to make sure that the hazards cannot be accessed. There's also guidance for the maximum sweep, the distance from the floor to the bottom of the fence. It's now not permitted to be over 7 inches. But again, depending on what is accessible, whether you can reach under the guard or not, it may be necessary to lower make the gap at the bottom of the fence even lower. We then have a new clause on nip guards, common in printing and web-based material processing applications, but much broader than that. There's many types of machines that have in-running nip hazards, and so providing general guidance on how to guard those hazards is important. And then the 2 clauses, the partial guards and the nip guards, have an annex that also support them as well, which we'll look at later. Moving forward, when we get into the control functions, as part of an engineered control or step 2, here you can see there's a lot of content that's included, and a lot of it's new. In the beginning, we have new requirements for safety functions, as well as safety-related application software that has an annex that supports that content. We have an annex that supports monitoring functions, which we'll look at. When we get into stop functions, We've always, at the last edition, we had emergency stop and protective stops. And as a contrast point, we've now addressed just a general machine stop so that we can better understand the differences between them. We've added a clause on reset, which includes safety-related manual reset as well as automatic reset of safety systems. We have a clause for safety distance, making sure that all your devices are mounted at a sufficient distance so people can't access the hazards, and a whole number of annexes, many of which are new to support that concept. We have new content on sensing field switching, most often applied with area scanners when you dynamically switch the monitored zone to match the hazard of the machine cycle. And then the concept of perimeter risk reduction measures, understanding the perimeters can be defined with awareness barriers as shown at the top, or with perimeter guards as we just talked about, or a combination of guards with devices. The next clause, 9.11, addresses the concept of whole body access, which is, in my opinion, a lot of really good work went into this, and it's now centralized this concept of all the things that can be done when whole body access is possible. You can enter into the perimeter and you're no longer detected. It includes control of the hazardous energy, either through lockout, tagout, or alternative means. It addresses prevention of undetected presence inside the safeguarded space. Then goes into safety-related manual reset. A new one is locating the safety-related control devices at a safe distance so they cannot be accessed from inside the hazard zone. We talk about inhibit functions, which include interlock blocking devices or slide bolts. We've now added the ability to open interlock guards from inside the safeguarded space. That could be locking or non-locking interlock switches. And the new clause also addressing initiation warning systems. Everything in this clause 9.11 is actually going to be addressed in more detail in a next white paper that SIP will be releasing next week. And the next webinar in our series will be looking more specifically at that application on its own. And then the last control function addressed is span of control, with a lot of good information coming out of other standards. Other B11.20 is another standard for integration of machinery into a system, and the concept of identifying which risk reduction measures are controlling or not controlling which hazards within the application. When we go into clause 10 with the devices, there's many types of safeguards or protective devices that are out there. Only a few are actually added as new. Again, there's a number of annexes that support all this content. New element that has been added is trapped key or captive key systems are now addressed in the ANSI B11.19, as well as vision-based protective devices, kind of an emerging technology, and acknowledging that they're out there and some guidance on how best to apply them. And everything else in this clause really was already existing. We have other presence sensing devices, two-hand actuating controls, single actuating controls either by hand or by foot, hold-to-run devices, enabling devices, and they are different, emergency stop devices, and slide locks. So all the devices that can be used as an engineered method to reduce risk are now consolidated into this clause to add more guidance. As we continue to the third step in the hierarchy, the administrative controls, this is where, again, more information was added, starting with the awareness means. We've always had barriers, signals, and signs. We've now added safety markings. So markings on the floor to help alert people of conditions or pending hazards within an area. And information for use, there's an annex as well that addresses the safety markings and all the awareness means, which we'll look at here in a moment. Next clause is information for use, which also includes guidance on instruction manuals and handbooks and what they should contain to be useful to help train employees to reduce risk. There's much content now added for supervision in the workplace and how to prevent things like unauthorized changes and how to manage change in the workplace. Control of hazardous energy, it's not a new concept, but it's new to the standard. Again, the intent was that B11.19 would be a complement to B11.0, and when you select risk reduction measures, 19 is kind of a one-stop shop, or at least a start to where you should go. And when it gets to lockout tagout, for instance, there's reference here to other applicable standards, in this case, the ANSI ASSP document Z244.1 for control of hazardous energy. And likewise with PPE, reference acknowledging that PPE is a risk reduction measure and then providing reference to where more information is available. So as you can see, there's a lot of new content that was added to the document. And as I referenced, there's a large number of annexes that were also added. We've added, there's approximately 100 pages in this document of the 250 pages that are simply informative information in annexes. And as you can see here, everything that's highlighted in dark orange is all new. So there's a lot of content that was added. It's very rich content. We tried to organize this as well. So we have a number of clauses or annexes that address guards. Some of those address safety distances, both for guards or for devices. We have a number of annexes that address the quote-unquote safe condition. So condition that's deemed acceptable risk. And then the annex on awareness means. Again, there's a lot of information here. I'm just going to try to go through these relatively quickly at a high level so you can understand the value. When we talk about reach distances or safety distance for guards, it's now in its own clause. And one of the first things that we addressed was the anthropomorphic data, the body measurements, the reach considerations of the human body. We've always applied it towards reaching towards the hazard, but the same information can be applied to make sure that we can't reach other things that could result in a hazard, like a reset device or a jog button. And so an introduction really of how to apply these measurements to any application to reduce risk. We then address reaching over guards, which we've always had the table. We've now aligned that table. We then address reaching through protective structures, whether it's through openings that are slotted, square, or round, if it's reaching through openings that restrict some movement of motion at certain joints of the arm, determination of strange openings and determining if it is square, slotted, or round, or how to treat it, guidance on whole body access and how to prevent it using physical structures, as well as indirect access to a hazard. A new concept also added that's, I think, new within industry globally is reaching under the guards with the arm. As I mentioned before, there's a maximum gap of 7 inches, which was a vertical measurement, but it never correlated to the horizontal distance to make sure the hazard couldn't be reached. So there's guidance for that as well. And then at the end, comparing all of those, the reaching over, the reaching through, and reaching under to ensure that the thing you don't want to touch, whether it's a hazard or a reset or some other control device, is out of reach to ensure that adequate risk has been achieved. We do a quick comparison on the reach distances. This is going to be addressed in more detail in a future white paper that'll come out in April and a webinar that we have slated for July. But looking what we had in 2010 on the screen and how it's changed to 2019. One of the things we did was we eliminated the low risk table for reaching over a guard. If there's a hazard and you can touch it, it shouldn't matter if it hurts a little bit or hurts a lot. It's still a hazard, and we want to make sure you can't reach it. So we've taken the approach of using a single approach to ensuring that hazards cannot be reached. With reach through, as I mentioned, we address the clarification of defining the shape as either slotted, square, open, or round. We've updated the measurement tool for reaching through slotted openings, through reaching through square openings, and have added reaching through round openings. So that's all been updated in a new table based on current international guidance rather than the previous data, which was based on a study from 25 years ago. As I mentioned before, reaching through with the arm with some limitation of motion, preventing whole body access and the indirect access, and then the reaching under, as I mentioned before, has new information. So what we've done here is aligned greatly with what's being done internationally for guidance for physical protective structures and guards, and created new content that we hope to propose to those international standards with the goal of getting more global alignment in the future. There's an annex I mentioned earlier about nip guards. There's, I think, a lot of good information here as well. First, defining what an in-running nip hazard is. Understanding it's not just conveyors and web-based applications, but there's many places where in-running nips occur. And then a lot of information, including figures of how to guard nips, whether it's side shields or across the face, the angle of approach, how to prevent wedges or pockets where the hand can get stuck, clarification of measurements where the hazard is and distances to make sure you can't get pulled into the hazard. And then a pretty elaborate example that shows a common application of in-running nips and how to use all the guidance in the B11.19 standard to adequately guard that application to still allow processing of material as necessary, but to prevent entry of parts of the body into the hazard zone. When we talk more about safety distances, we also talk about it in terms of devices, and there's a calculation many of you may be familiar with. This calculation now is in its own annex. One of the things that was done was the variables were modified, and so on the left what we see is a table that was provided to cross-reference the new variables to the old, both in the previous edition of B11.19 as well as other international standards. And essentially, it's just laying out the formula. The overall distance is a factor of the approach speed K times the overall time to achieve a safe condition T. And we know that T has different subparts associated with it. So the device, the interface, the control system, and the machine. Time is also a factor that can be applied for guard locking devices. That's addressed here as well. To that, we add the reaching distance factor, which has an annex unto itself of how to determine the reach distance based on the technology and the application. And then supplemental distance factors that are new that have always been addressed by manufacturers of the devices. When we talk about the reach distance, we have a lot of information here again, addresses reaching out, addresses the angle of approach, so you know how best to apply it. When it's a vertical application, we address reaching over, reaching through, and reaching under in comparison of those, just like we did with the guards. When it's a horizontal application, we talk about the reach distance, the mounting height, the depth of the field, a number of considerations that apply there. We've added single beam devices when used as a standalone risk reduction measure. Two-hand controls have always been there. Single actuating controls, we added guidance for distancing of foot actuated controls like foot pedals. RF devices have always been there. A lot of work went into interlocked guards, very common application that people often don't necessarily consider the safety distance with the interlocking portion of the guard. And so a lot of guidance was put in there, as well as with pressure sensitive protective devices like safety edges and bumpers. So again, this is just a quick overview. It's going to be in a future white paper, probably in May, that'll come out with a subsequent webinar in September. But some of the stuff that has changed, as you can see, the reach over table was added in 2019 that wasn't there before. The arm length reaching through presence sensing devices is now harmonized globally at an appropriate length of 850 millimeters. We added guidance for reaching under presence sensing devices, just like we did for the guards. We also added information for determining the maximum gap beyond a horizontal field in the machine. Single beam devices were added, two-hand control actuating devices with shrouds, without shrouds. There's now guidance for that, as well as the single actuating controls, both foot and hand actuated, the interlock guards, including interlock guards with rotary cam or hinge switches and bumpers and edges. So as you can see on the screen, all the red stuff is new or changed from the previous edition. So it's a lot of, again, rich content here addressing safety distances. We have information also for safety functions for power drive systems, just high level, addressing different stopping functions you might have heard of or be familiar with, like safe torque off, safe stop 1, safe stop 2, a handful of monitoring functions like safe operating stop, safe cam, safe speed, safe temperature, safe braking functions, a lot of guidance here. And then the last annex we'll talk about here briefly is on awareness means, Annex N. Within this, there's guidance for selecting appropriate colors for indicator lights and icons, both with a preferred condition as well as alternate conditions, whether you're showing condition of the machine, the safety of people, or the state of the equipment. Some guidance on awareness or safety signs, understanding that the selection of the type of sign is based on frequency of exposure as well as severity of the hazard, which really is just risk assessment, and the guidance on how to design and select those signs. And then guidance on color coding and application of awareness markings on floors with intent so that it can actually be standardized within a facility. So what this shows us is a lot of information being added, obviously. And what we try to do is align with and converge a lot of good information from other B and C type standards out there, not only domestically, but internationally as well, to update it, to provide it in a single location so that it really can be used as a counterpart to ANSI B11.19 when moving to the application of risk reduction measures. So I know I went pretty long, and I'm going to take a break now. I'm going to pass it over to Dave and ask him to share some information about how this ANSI approach compares to the international approach of standardization.
Thank you. So Chris touched on this briefly at a very early slide, so I'm going to spend a minute or two and just explain a little bit more about comparing directly ANSI with the ISO and IEC portfolio. So you can see that with the 12100 standard, that standard actually references, it has a few references, but it relies on the, next slide please, Chris. It relies on a very large number of individual ISO and IEC standards, 13 different ISO standards that deal with all types of specific kind of components or concepts, things like light curtains, two-hand control, interlocks, minimum gaps, positioning, safeguards, pressure-sensitive protective devices, safety distances, unexpected startup and emergency stops, design and construction of fixed and movable guards, information for use, and so on and so forth. So the contrast here is that you have, these are all individual kind of pieces of a puzzle, if you will. And within the ANSI B11.19 standard, we put all of those pieces into the whole puzzle. So you get the entire thing pretty much covered in one standard. The next slide shows a similar comparison using the same portfolio of documents, looking at the age of the documents, revised or all the individual publication.
Dave, it sounds like we're missing some of your audio right now. Maybe Chris, you can take over?
Yeah, I'll fill in for Dave.
Okay.
Seems like we might have lost him. So what Dave was saying was looking at the same portfolio of B-type standards internationally and the age of them, how some of them are nearing 15 years old already, whereas if we compare that to the content as it was updated and refreshed and put into B11.19, it was refreshed and updated to make it more applicable to current state-of-the-art and current best practices for application of the different measures. Also looking at it from just a simple market barrier standpoint of cost, to actually go and obtain all of those standards, the cost of that when converting the Swiss franc cost to US dollars is over $6,000. Not that everyone would need every single one of these standards, keeping in mind that these standards in the international approach are really meant for suppliers and integrators only. But what we find in there is that there's still information in most of these standards that help with the application of risk reduction measures, which in North America, that's the responsibility of the end user, thanks to OSHA and the regulation that we have. So actually obtaining all these standards in an international model is quite costly, which unfortunately is a barrier to most small and medium enterprises to obtaining this information. Whereas if we look at ANSI B11.19, that cost is very drastically different. It's less than 6% of what it would cost to go and get all those other standards. Now, if you're in the business of building interlock switches or light curtains, obviously you're going to want to have those international standards as well. But from a sheer application and validation standpoint in the marketplace on machines already deployed, you can see that the cost barrier is much lower. If we look at it from just the usability aspect, if you're designing, installing, or validating common examples. So I picked two examples here to look at. One is an interlock guard. Most of us are familiar with interlock guards. And we're just looking at just the input and the logic function. If I wanted to figure out how to design and implement the guard itself, the standards I would need internationally versus domestically, the interlock to put on that guard is going to have different standards. If I want to apply a slide bolt, an inhibit function, there isn't even a standard out there internationally that addresses this. B11.19 is the only standard that gives guidance for slide bolts and other inhibit functions. Then we have the manual reset, and then coupled with that, the safety-related part of the control system, the logic unit itself. So you can see in an international approach, you'd have to obtain 6 different documents to get not even all of the information that's already contained in ANSI B11.19. We look at another common example of a light curtain with a muting function. We have, again, different standards that apply to the application and design and some of the functionality of the light curtain. Yet another standard for the application of the muting sensors. Again, we have the safety-related reset, as well as the safety-related part of the control system. So here again, we have 6 different standards that would have to be obtained to get some of the same information that's in the one single document of ANSI B11.19. So as we summarize and start to wrap up the webinar before we open for questions, really what we wanted to highlight today was some of the value-added benefits of ANSI B11.19. Obviously, we've added clarity. It addresses a complete market audience, not just suppliers, but end users as well. It complements the risk assessment and the risk reduction. As Dave mentioned, it kind of it provides the complete picture of all the elements that are out there. It's aligned with state-of-the-art and current best practice. The barrier to entry in terms of cost is relatively low. It is a single source document to begin your journey of risk reduction, and we've tried to organize it in a way that makes it usable and readable and understandable. So by doing so, what we tried to do is create a single basket of information with a high level of value in it. So you might be asking where more information is available. Well, within SICK, we have a number of resources that are available for you. One is our blog at sickusablog.com. There's information there that's updated regularly. There's a number of white papers that we have on our website. Of these, there's a 6-part series that we're developing currently. The first 2 are already published that were the basis for today's webinar. There are more to come, the next one addressing whole body access, and then others to follow. The safety ebook that I mentioned early in this presentation is also listed there, as well as a number of other white papers that you may find useful. And then as mentioned, this webinar is the beginning of a 4-part series, so stay tuned to our website and you'll see when the future webinars are published there as well. If Dave is back online, hopefully, I can hand this over to him. And if not, I can fill in for him. Yeah, I can hear you, Dave.
Okay, good. Sorry about, I don't know what happened when I got dropped off, but anyways, you are invited to obtain the copy of the brand new B11.19 standard. A couple of sources that you can get both the electronic versions are the ANSI web store itself at ansi.org or the B11 Standards website, b11standards.org, current standards. If you're interested in obtaining a print copy, harder and harder to get print copies of standards these days, but I believe TechStreet does still sell print copies, as well as Global Engineering, which is part of IHS Global.
So with that, Lisa, I think we're ready to open it up to questions.
Great. Thank you, Dave and Chris. As Chris just mentioned, we'll open up for some Q&A, and we have some that have already came in. Our first question is, does ANSI B11 address safety and integrity levels like SIL and/or PL? And how is the risk level evaluated and validated?
That's a great question. There was an earlier slide, which I won't try to jump back to, but there in the international world, we have ISO 13849, which addresses performance levels or PLs. There's IEC 61046, 62061, 61508, a number of them that address safety integrity levels. B11.19 does not delve into that part of the risk reduction measures. This is more with the measures themselves, how they integrate into the machine, into the safety related part of the control system. As a counterpart to those international standards, there's in the B11 family a standard called ANSI B11.26, which, Dave, if I recall, has a 2018 publication date on it, which is a guidance for how to design control systems with safety, integrity, or performance level according to or commensurate to the level of risk. So B11.19 doesn't go much into how to do the circuit design. It's more the application of the measure itself. And then B11.26 would be the counterpart B-type standard to be used for the actual guidance for the design of the circuit that those measures are integrated into.
Which is actually somewhat of a segue into the next question that deals with U.S. adapting performance level ratings versus SIL ratings to be achieved for safety devices and components, or are they both ratings still applicable? So the B11.26 standard talks about the different methodologies. So the PLs or the SILs are, as well as categories, as well as control reliability, those are all different methodologies. Not to say that one is better than the other, it's just simply that you have the flexibility to adapt your approach or your architecture to use one of those methods, or whatever you're familiar with. There's many large corporations that still use or choose not to use PLs. And it's not because they don't understand it, but it's just because it's not particularly applicable to their needs. I'll just touch on this very briefly, but there was an effort several years ago that began between ISO TC199 and IEC TC44 to try and merge those two standards dealing with PLs and SILs together. And it really went down in flames. It crashed and burned. So there have been attempts in the past to harmonize those. They were unsuccessful. I don't see that particularly reviving at the present time.
And another thing to add to that as well is one of the differences between SILs and PLs. SILs really only address the electronic, electrical, or programmable electronic systems of a safety function, whereas ISO 13849 addresses the overall performance level. That could be electrical, hydraulic, pneumatic, other power sources. The B11.26 document better aligns with ISO 13849 and the performance levels, because in reality, most of today's industrial equipment is more than just electronically controlled. There's still fluid power. There's still other energy sources that need to be controlled in a reliable fashion. So 13849 and B11.26 are better aligned that way, but the B11 family doesn't reject or omit safety integrity levels, just acknowledges that most machines have multiple energy sources that are not electrical.
Great. We have time for one more question. And just as a reminder, this webinar was recorded and will be sent out to you about 24 hours after today's presentation. So Chris and Dave, the last question has to do with the international standards. And the question is, if B11 aligns with all of these international standards, does it mean that if we design according to B11, we will meet all of the international standards as well?
The intent is that we will eliminate conflict between international and domestic standards as much as possible. As we showed on the age slide, some of those international standards are old and starting to become outdated. And so while we did draw on them as much as we felt appropriate, we also acknowledged there were times when then the information in those international standards wasn't correct, it was incomplete, or was in some cases not best practice moving forward. So it's hard to draw a line and say absolutely yes or absolutely no. The intent is that applying either an international standard or an ANSI standard, you'll end up at the same place, which is acceptable residual risk. So in that aspect, from a theoretical approach, yes, they are aligned. The actual distances, the measurements, even safety distance, some of the stuff there, we have more conservative or more updated approaches that go beyond the international standards. Sometimes the international standards were outdated and had distances that were too long and not justifiable. So it's not a black and white yes or no, but theoretically, yes, you would meet the same intent of achieving acceptable residual risk, regardless of what set of standards you apply.
And I'll add on to what Chris just said and point out that, first of all, the answer to that question is actually a very complicated one and deals a lot with things like cultural differences between the European, or the ISO world, which is Eurocentric, and North American approach to standardization. The other thing I'll point out too, which is interesting, is the fact that the ISO portfolio of standards, many of those are beginning to undergo revision processes at the moment, and virtually all of them are looking to B11.19 as a kind of guidance or template, because they realize that this is not only a very comprehensive standard, but a very current standard. So it's kind of an interesting flip-flop of what we've seen in the past, where the ISO folks tend to look at the North American portfolio standards and, it's a NIMBY approach, not in my backyard kind of thing. Now they're very much openly looking at our standards to try and emulate or copy some of the information that's in there.
Great, thank you, Chris and Dave. I see some more questions come in, so I will have Chris and Dave reach out to you to answer any follow-up questions. And so that is all we have time for today, and we really appreciate everyone logging in. We hope to see our listeners again soon. Please visit SIC.com to stay in the know on our upcoming webinars and our next white papers. Have a great day. Thanks.
Thank you, everyone.
Thank you.